So, ipXchange has talked about Ambiq's Apollo 4 MCU many times, but today, Ambiq are bringing out Apollo 5, which offers 11 times the AI performance of Apollo 4 and still gives you the same battery life. Check this out. Hey, it's Eamon with ipXchange. I'm here with Scott Hanson, CTO of Ambiq, for a product release, which is very exciting. You may remember Scott from a conversation that he had with Guy earlier on.
So I founded Ambiq 13 years ago. Today I'm CTO of the company. That means I drive technology forward. I make sure that we continue to offer the lowest power chips on the planet.
But today we'll be talking about Apollo510. So Scott, first of all, welcome to the ipXchange studios. Great to have you back and lovely to meet you. So what is the Apollo510 and how does it differ from the Apollo 4?
Well, Apollo 5 is, let me start by saying it's the most ambitious product we've ever built. It's the biggest, it's the fastest, it's the lowest power that we've ever built. And I'll get to some of the differences relative to Apollo 4, but the big thing with Apollo 5 is we're attacking an endpoint intelligence opportunity. So we've all seen the chatter and discussion around cloud-based AI, right? And it's for good reason, right? There's amazing things happening in the cloud. Well, the bigger story in our view is happening at the so-called endpoint. A lot of people talk about the edge. The endpoint is one step further out. It's all these devices around us. That's our watches. It's smart sensors in our homes, in our buildings, et cetera. All of these devices need intelligence. They need to be able to run inference efficiently, and all the stuff that goes with it, security and UI and graphics and everything that comes with it. Apollo 5 is meant to be the ultimate solution for exactly that problem, and it is the lowest power processor that we've ever built, and all of our previous generations have been the lowest power processors on the planet. So. Apollo 5 is, in short, it's a Cortex M55 based microcontroller. So it uses the ARM Cortex M55. Previous generations had used the ARM Cortex M4. And one of the benefits of the M55 is it's very efficient for machine learning as well as signal processing. So really good general purpose workhorse. And so when you're running AI workloads, it is more than 4 times more efficient than Apollo 4. Okay, so this is a big deal, right? That's a really big leap, especially for a product that was already lowest power out there. And what's amazing is it's a bigger processor than the Cortex M4. But if you compare even Apollo 5 and Apollo 4 side by side, running simply while one, so the simplest program you could run, it's not doing any math. It actually consumes less power than Apollo 4. And that's because we've deployed a lot of new optimizations here. We're running at slightly lower voltages than before. We've deployed a lot of other low-level optimizations that enable active power to be substantially lower. Of course, back to what I said earlier, where it really shines is when it's running AI workloads or DSP workloads. And, those workloads can be anywhere from 3 to 15 times more efficient, meaning they require 3 to 15 times fewer cycles than on a comparable M4. And then the other big difference on a performance side is that we have a GPU on board, which we did before, but this GPU is nearly 4 times more performant than the previous version on Apollo 4, and that's both because we're running at a higher frequency, but we are also we've introduced some new architectural enhancements to make it more efficient. So this thing is, as I said earlier, it's the highest performance product we've ever built and the lowest power.
Wow. Just getting onto that GPU. So I was reading some of the specs from some of the details that you sent before this interview. Can you just quickly explain what a 2.5D GPU is and how you use that in a wearable? Yeah.
So in short, customers have long dealt with a 2D GPU. You can do two-dimensional graphics. They want something bordering on 3D graphics, and so 2.5D is kind of a step between. It's not a full 3D graphics solution. It's partway there. And what that was motivated by is, look, we're all used to having our phones, and we're used to the amazing graphics experience you get there. And we expect no less of devices like this that are worn on our wrist or that we're interacting with in smart homes. And so our customers have really driven us to offer a really rich experience there, right? And that means a couple things. It means having support for these 2.5D features. We don't need to get into the details of exactly what those are, but the upgraded GPU was important for us. Also really important was having big memories to support that and close-in memory. So, one of the other big improvements in Apollo 5 is that it has huge memories. We have 4 MB of on-chip MRAM of non-volatile memory, and then we have 3.75 MB of on-chip SRAM. And all of that is on chip. Okay. When you're building big graphics intensive applications or even AI applications, hugely beneficial to have big on chip memories. The minute you go off chip, you're spending big energy, right? There's big performance impact and there's big energy impact. If you can stay on chip, that's a big deal. And so we put those there. You can put frame buffers there. You can store graphics assets there. You can store neural network weights or activations. So really good on-chip memory storage system. And one thing I'll call out is we've always opted to put NVM on chip as well as a lot of SRAM on chip. A lot of our competitors these days are starting to pull, because of the complexities of non-volatile memory at advanced process nodes, they're pulling non-volatile memory off chip. And maybe it's still in package. Maybe it's a die. It's a NOR flash die that gets put on top of the main die. So to the customer, maybe it looks like there's non-volatile memory in the part, but when it's off die and it's stacked like that, you end up paying a huge energy penalty, and it could be to the tune of 2 or 3 times higher energy at a system level. And so it was really important for us to put that, to put that memory on chip. And then look, customers use a lot of memory. Okay, that's one thing. Software guys will say that what I need more processing horsepower, and I need as much memory as you can give me. And so inevitably they're going to go off chip, right? You want to keep the stuff that is commonly used on chip so that it's quick and it's low energy. But when you go off chip, you want to as fast an interface as you can get. That allows you to transfer data quickly and then shut that down. And so we did enhance the interfaces on this chip as well relative to Apollo 4. So big performance boost. We've got a whole variety of interfaces that can achieve maximum throughputs on the order of 500 megabytes per second, sustained throughputs on the order of 300 megabytes per second. So we're talking about really high performance interfaces, and a lot of them. We've got SDIO, eMMC interfaces for NAND flash chips. We've got SPI interfaces that are up to 16-bit wide to talk with PSRAM chips and NOR flash chips. We've got USB interfaces. So this is a really rich, interface-rich chip as well.
Excellent. Another thing I wanted to ask you about is because in the documents that were sent forward, it highlighted that this is AI without a micro MPU. So what was the decision? What was behind the decision to go not with a micro MPU? Because I understand that the M55 is really, really good with AI generally. But yeah, how can you explain that a little bit?
Yeah. Well, so at a high level, if Carlos Morales, our VP of AI, was here, what he would say is 75% of the applications in the deeply embedded world, the endpoint, don't need an NPU because they're using relatively simple neural networks, and frankly, NPUs are a big overhead, right? You've got to write code separately for it. You've got die area that's being taken up by it, and in the end, there's a lot of neural networks that need to run once every 10 minutes, right? And you're running that every 10 minutes, and so it doesn't matter if it's a little less efficient on an MCU. And the other thing is this: if you look at a lot of the use cases for our customers, inference is just a tiny little sliver of the work that they're doing, right? They're doing, you have sensing work that's happening. So we have these great ADCs and sensor interfaces. You have pre-processing. So you've got FFTs and stuff as you build spectrograms, et cetera. You got the inference itself. And then you've got all these other things like security and operating system and communications and power management. And so, to devote too much silicon area to inference would potentially do a disservice to all those other pieces there. So Apollo 5 is a really truly well-balanced solution for all of that. And this came out of discussions with customers too, right? We were talking to customers and saying, give us the forecast of how complex the neural networks are that you're looking to build. And there is absolutely a complex end of the spectrum that likes an NPU, right? But the vast majority of them had very simple use cases. With all that said, you and I were discussing briefly before this recording here, there will be future Apollo family members. You can expect to see NPUs coming, because we do believe, as I said, even if 75% of the markets we want to chase don't need an NPU, there's that 25% that does need it, right? The minute you introduce a camera, for example, there's a lot of data. A camera spits out a lot of data, and so having an NPU there is highly beneficial. The other thing I'll say about NPUs is this. There's a lot of excitement around an NPU that can do, for example, 128 or 256 multiply accumulates per cycle. The problem that we've seen as we've built a lot of our own internal networks is you can't utilize all of those max because of memory bandwidth in the system, because of relatively narrow memory bottlenecks. It's hard to utilize a significant fraction of those. So when you have a relatively small Mac unit, like M55's 8 wide Mac unit, it's actually much easier to fill that, right? And so you can get more efficient operation. You can be more fully utilized. And so the performance uplift of an NPU can be really big, okay? But for a lot of network types, it actually isn't as big as one might think, simply because you just can't fully utilize the Mac unit. So in time, we'll get there. For now, Apollo 5 is the ideal solution for the markets that we're chasing.
Excellent. And can you give an example of some of those markets and the type of workloads you'd be running on the on Apollo 5?
Well, First of all, of course, today we have a lot of customers in the consumer wearables market. So, smartwatches and fitness bands and this sort of thing. And this product is ideal for them. And we see customers that are using it in two different modes. They're using it either as the main processor that's running everything, running graphics constantly, managing all the sensors, et cetera. And then there are customers that are using it as a co-processor. So imagine that you have a big processor running Android or something like that. We can be the co-processor next to it. And that's a model that we use on Apollo 4 and Apollo 3 today as well. Either of them works. So wearables is one. Health devices, digital health devices is another big one. And some of them very literally look like wearables, right? They're watch form factor devices, but they have a more clinical focus. Apollo 5 is great for that. And in both of these cases, we're seeing a lot of really interesting AI use cases. A lot of the customers are taking traditional algorithms for sleep detection or for heart health management, and they're replacing them with neural networks. And some of them are advertising and some of them aren't. And the net result is you get a much more accurate performance. So suddenly your heart rate algorithm is much more accurate than it was. Your sleep detection performance is much more accurate than it was. And so that's exciting for us. But we're also seeing some more aggressive uses of neural networks. Customers that are adding voice to products, so speech recognition or command keyword recognition. As well as if you look at some of the stuff we've been doing on our side, we have some speech enhancement models that are really exciting that fit on Apollo 4 and Apollo 5. So we're excited about all that. Outside of medical devices, we're also seeing some industrial use cases. So we have customers in industrial machine health monitoring. So I mean, it's almost it's a fitness tracker for your machines, right? You've got a factory floor, you've got a bunch of pieces of equipment, legacy equipment, probably in many cases that aren't wireless or anything like that. You go throw a little wireless sensor on there, and it's monitoring vibration, it's monitoring sound, it's giving you a sense of condition of the equipment, and it's identifying anomalies. When the vibration signature changes or the sound signature changes, maybe that signals impending failure and we've got to come out and fix it. So we have customers doing that. And the cool thing about Apollo 5 is we've substantially increased the amount of inference that they can do and the amount of signal processing that they can do on this little platform. So We're seeing a lot of interesting use cases that span wearables, health, industrial, and much more. But I'm really excited to see where customers take it. We've got a bunch. The product is sampling to a number of customers right now. We've got all we can handle, and we're really focused on getting these customers to market as quickly as possible. We'll have more general sampling in the fourth quarter of this year, but for the moment, a lot of great customers with products that I'm really excited about coming out.
Cool. So you mentioned kind of predictive maintenance in industrial settings, which I always imagine putting something into somewhere where you're never going to be able to easily get at it. So does the Apollo 510 have any wireless connectivity, or do you provide that via another source? Because I know that the Apollo 4 had a blue variant.
That's right. Yeah. So the both Apollo 3 and Apollo 4 families do have Bluetooth Low Energy support. The initial member of the Apollo 5 family, Apollo 510, does not have onboard wireless connectivity, and frankly, that was driven by customers. Customers have different needs. Some customers need Wi-Fi, some customers need dual mode Bluetooth Classic plus BLE. What you will see is some forthcoming Apollo 5 family members that do have integrated wireless connectivity. I'm going to tell you right now, BLE will of course be included, and there will be other wireless standards. I'm not ready to pre-announce those, but there will be other non-BLE standards. We'll come back and talk about it once we.
I'm sure we will. Excellent. So, and you said that these are kind of. Was it mass market or just still sampling by the end of the year?
Both mass production and sampling widely by the end of the year. Yeah. So as I said, we've got a number of customers using it today, and we really are intent on making sure that they've got successful launches.
Cool. I don't think we've talked about security on the device yet. So can you go into that? Because when you shared me some of the slides, I saw quite a few points on security.
Yeah.
So
yeah. So I mean, first of all, this is motivated. We can sit here and paint beautiful visions about what AI is, right? And it's exciting, right? But then you start talking about eyes and ears everywhere, and that starts alarm bells ringing, right? Okay, so security is really important. People freak out a bit. So it was very important from the start in Apollo 5. It was planned as to be a highly secure part. So first, this part has ARM's trust zone technology.
Oh, cool.
We have support for secure boot as well. And then there really critical is there is support for secure lifecycle management. And the idea there is when I give the part to the customer, it's unlocked. It's fully accessible. They can do whatever they want to it. As they go through their development process, they can step up security in discrete steps. And by the time they give it to their customer, it can be fully locked down. The debug port can be locked out. All their code can be protected. All their secrets can be protected. And then, should there be a return from the field where they need to get back into the device, they can step back down the level of security. So we have all this functionality built in. It will eventually target PSA level 2, and that's something that will be forthcoming. But highly secure part, and then also we of course support secure over-the-air updates as well. So if customer, this is very regular. We have customers that want to send a new image to incrementally update their code. They can do so. They can authenticate that image and make sure that it's coming from them and not from a hacker.
Excellent. And talking of code, actually, I should have mentioned it back when we were talking about AI. I can't remember if it might have been when I talked to Carlos. He talked about the kind of the software development side that's been done by Ambiq to help customers really get their hands on that, get their hands working with AI. So in terms of how you program those workloads, is that done using kind of commonly used other platforms, or is it a proprietary kind of Ambiq kind of deal?
Yeah. So it's a mix of the two. So we want it to feel very familiar. So first of all, when you're writing general purpose code, you're working in a standard IDE like, Kyle or IAR or whatever. You can use the whole GCC, GDB flow if you want as well. And then we provide a whole set of libraries. When you sit down to write neural networks, we're providing a couple things to you. First of all, you can build the neural network in TensorFlow, as you would elsewhere. So you can build it in TensorFlow, and there's this whole TensorFlow Lite micro signal chain. But that doesn't get you all the way to bare metal hardware. There's a whole layer of software in between that we call NeuralSpot, which is a set of utilities and libraries that allow you to get from TensorFlow down to Apollo. And then there's a bunch of other things in there. ARM provides something called SimSysNN, which gives a library of pre-mapped functions that map well to the M55 or to the M4. So we provide that to the customers, and that gets them up and running quickly. What really helps, though, is we also have what we call ADKs, AI Development Kits, and these are reference designs for neural networks, basically. And it's stuff that we train in-house. We've got a number of PhDs who are experts in building neural networks, and they've gone out and built things like Heart Kit, Sleep Kit, Physio Kit. There's another one called Neural Network Speech Enhancer. And these are neural networks that we built in-house that are open source. We provide the training data. We provide everything a customer needs to get started. And it's not that we expect customers to just use these and take them to production. We expect them to take them and build upon them and use it as a seed for their own development. We find that customers are often afraid of doing neural networks. It feels like this unobtainable thing. And I admit, 6 years ago when we first got into this, I felt the same way. Okay. But the truth is, once you get into it, once you take all these little seeds that we give you, it's very straightforward. We've got a number of people here developing neural networks, developing quite high-performing neural networks, and it's our goal to make it easy for the customers. One thing I will say is this to those customers who do take this on. Yes, there's opportunities always for optimization at the hardware level. Hardware accelerators are cool, but you're leaving probably 10x worth of optimization on the table if you don't really focus on hyper optimizing the software piece of things. And that's both architectural optimizations, but also how well does the software map to your hardware. And one of the things that's great about Apollo 5 and about the M55 is there's a bunch of great profiling tools. So they have something called the Performance Monitoring Unit, the PMU, and it allows you to monitor all kinds of things like cache statistics, how well are you hitting in your caches, but also it can tell you how many vector instructions have been executed, how many of various instruction classes have been executed, how many load stores have been executed, and it's great to take this data to look at it and go, wait a second, I'm running at maybe 10% of what I think I should be running at. So we make an attempt. We at Ambiq are really working hard to make sure that our customers don't have to worry as much about that. But I strongly advise anybody who's building deeply embedded neural networks, you've got to focus on this, right? You've got to really think about how well the software is mapping to your hardware.
Cool. And this is a question that Guy loves to ask. And because we're already talking about customers, if someone was coming to you to try out the Apollo 5, what would your ideal customer look like, do you think?
So at a highest level, I want a customer that says, hey, I'm happy with my battery life. I like the size of my battery. What I want to do is I want to do 10x more compute than I did before. And we have, and that spans every market, right? It's somebody who's looking to add more intelligence and just can't do so today. They're limited by their battery, right? Because there's three ways to exploit low power. You can extend your battery life. That's cool. Okay. But by the time you get to 4 weeks battery life, maybe you don't need any more, right? Smaller batteries are also cool, right? Because I can build slim form factors. Not everybody loves a huge chunky device like this, or it's a medical patch and maybe it needs to be thin. That's cool. But for me, the most exciting is when a customer comes along and says, we want to do 10x more compute and keep everything else the same. And it's hard for them to do that, right? You can't just magically do that. And that's where Apollo 5 shines. So, and it's to do all that stuff. Some of it is going to be to do what I call small AI. That's where we're replacing, existing algorithms with neural networks. And that's, you're not adding anything maybe that new or exciting, but what you're doing is making it better, incrementally better. And then there's the big AI, right? We're going to see devices like watches or smart home devices where we can talk naturally to them. And I'm not talking about full on natural language understanding that like a chat GPT might have. I'm talking about expert systems that know, hey, I'm a watch and there's only 100 different things that a watch can do, and so I'm gonna know how to understand the speech for those narrow 100 things. We're gonna see. I would call that more of a big AI use case, and I'm excited about that stuff. So the ideal customer wants to do all that kind of small AI and big AI.
Nice. So if a customer came to you, what kind of evaluation kits do you have at the moment, or have you got planned for the Apollo 5?
So when we have general availability in the fourth quarter, we'll have the standard evaluation kit that we've always had for our customers. We'll have it's going to be Arduino compatible or Arduino Shield compatible, so we can drop various shields on there. For example, we have Display Shield, which is drop it on, you get a nice display. You can mess with the GPU and all that. We have support for audio functions, etc. So will be a really nice modular evaluation kit available later this year, consistent with the Apollo 3 and Apollo 4 families.
Nice. And I think we've had a great chat. I'm not sure how you found it, but I'm very much energized and excited to see this.
Good.
in
I appreciate
person.
that, yeah.
So because these chats are quite long, what I quite like to do is ask my guest if you can summarize the 3 key points for this new product in what would you say?
So I would say 3 things. First of all, it's the lowest power product we've ever built. Apollo 5 is. It is the highest performance product we've ever built for machine learning, for DSP workloads, for graphics, and it's the most secure product we've ever built. I think these are the 3 key things: extreme low power, high performance, very secure.
Excellent. Well, I think we'll leave it there. You guys are going to be at Embedded World, aren't you?
We're going to be at Embedded World. Yeah, look forward to seeing you and to seeing all of our customers there.
And I believe, are you doing a speech or a talk as well?
Yeah. I will have a talk. I can't remember the day, but I'm going to be talking a lot about bringing AI into resource-constrained devices like Apollo 5, Apollo 4, Apollo 3. And so it's about how do you fit AI in a world where we care about sense of cost, we care about kilobytes and megabytes of memory, microwatts of power. It'll be fun. It'll be informed by some of the real engagements we've had with customers and some of our own internal development of neural networks.
Excellent. Well, by the time this goes out, I think it'll be 2 weeks to Embedded World. So anyone who's going, check out Scott's speech. I'm sure it'll be really good. I probably won't get to see it because I'll be running around doing lots of videos. But yes, Ambiq Apollo 510. I'll do a write-up for you all to have a look at the technical specifications in a bit more detail. And thank you so much, Scott, for joining us again. And yeah, this is very exciting. So thank you for sharing it with us.
Thank you. I appreciate it.